Hello. In this session, we'll go over some basic understandings of logs and exponents. First, let's just understand what's a log anyway. What's the whole point? It's simply a way of writing out an exponent or exponential function using another type of function symbol. For example, if I gave you log base 2 of, this is log of 8 base 2. What does this mean? This simply means 2 to the what power is equal to 8. A log is nothing but an exponential function. It's just the exponent part. It's a log is the power, but it's just the exponent part. So for this, log base 2 of 8, it's equal to 3. So let's understand this. What if I gave you log base 5 of 25? Now it should be easy. Just a basic understanding. We're saying 5 to the what power is 25? Well, duh. The answer is going to be 2. Yes, I did say duh. It's okay. So 5 squared is equal to 25. Well, again, a log is nothing but an exponent. This represents an exponential function. This represents a log. These two functions, when graphed, these are inverse functions of each other. And we're going to look at that in a minute, but you need to have that basic understanding of what a log function is. Well, let's look at some behavior of log functions and exponential functions. It's good to just try to figure out the patterns just by graphing some functions. So I'm going to go to my advanced grapher, and I want you to be able to do this. Okay, go to your advanced grapher, open it up, look for this. We're going to add a function. Let's graph y equals 2 to the x and see what happens. 2 to the x power. We're going to graph it. Let's say I want my line to be bold, and I don't know, let's use this color here. That's y equals 2 to the x. Does that make sense to you? Well, let's go to a table to look for some values here. I'm going to pull this down, drop menu here, calculate. Okay, I need to make sure I highlight that, calculate. Now here, these values correspond to the values in the graph. Notice at 0, at x equals 0, y is 1. Well, that's the function. Y equals 2 to the x. You plug in a 1, 2 to the 1 power is 2. Plug in a 2. 2 squared is 4, so forth. What if I plug in a negative 1, which is here? Well, that's going to be 2 to the negative 1 power. 2 to the negative 1 power is a half. 2 to the negative 2 power. We're going to get a little closer, a little closer. We're going to continually get closer and closer to the x-axis, continually, until it will never touch 0. So if I need to calculate the domain and range of this function, to understand, your domain is how far to the left does this graph go and how far to the right does it go. Well, let's look at my trace function on here. Let's get rid of this. And I believe this is trace. Watch this. I'm going to trace. Look at this. How far to the right will this go? X value will go on forever, forever. It'll keep going forever to the end of time. So my domain will go as far to the left and far to the right. Is going to be all reals. My range for this particular function, how high will it go? It goes to positive infinity. How low will it go? Well, it won't go past 0, as I stated. So your range is from 0 up to infinity. And I could just write that as y is greater than, but not equal to 0. It will never equal 0, but it will get very, very close to 0. That's your domain and range of this type of function. On the next part for this particular graph, for this particular section, we're going to look at the function of a log and see what it looks like. So this is part 1.